In today's lecture, we'll be looking at polynomial and synthetic division. Now remember, our goal in this section is to be able to find all the zeros of a given polynomial and to be able to factor it completely. So, with that in mind, we're going to start building up some tools. And right now we can't find zeros very efficiently, so we'll just have to assume we know what some of the zeros are and go from there. So let's say we graphed f of x is equal to 6x cubed minus 19x squared plus 16x minus 4, and then we just looked at the graph and saw it has a 0 at x equals 2. From the last section, we saw that if it has a 0 at x equals 2, this means exactly that we can factor out the term x minus 2 from our original function and have a nice polynomial on the side. So what this should look like is 6x cubed minus 19x squared plus 16x minus 4 equals x minus 2 times something mysterious. And what polynomial division gives us is the ability to find what this mysterious new term is, and it'll be something simpler, so we can start going down and down to simpler functions until we can factor it. So let's start talking about long division of polynomials. Now, long division of polynomials is actually very similar to long division of numbers. So we'll define some terms, and then for the rest of the section we'll primarily look at examples so that we can get the ideas down. Alright. So if we're dividing two things, then we'll have two functions that we need to consider. We'll have the original function and what we want to divide by, which we'll call the divisor. So for this example we're working out, our original function is this 6x cubed minus 19x squared plus 16x minus 4, and the divisor is what we want to pull out, which is x minus 2. Once we know what these terms are, the division itself is pretty easy. The first step is we take the highest term of the original function, so that's 6x cubed, and we divide it by the highest term of the divisor, which is x. So this 6x cubed is this 6x cubed right here, and this x is this x on the bottom, original divided by the divisor. And with this simple division, we can say, okay, one of the x's is going to cancel out, and we have 6x squared. This term that we come up with is exactly what we write above the divider, and like normal long division, we multiply it by the divisor, subtract, and keep going. So this should look something like the following. Here's our divisor. Here's where our polynomial goes. And the setup is exactly the same for regular numbers here. Now we checked what is 6x cubed divided by x. That's 6x squared, so that's the first term of our new polynomial. And we take 6x squared, and we multiply it by everything here. And then once we do it, we subtract it from the bottom and keep going. So let's do that. Okay, 6x squared times x is 6x cubed. 6x squared times negative 2 becomes minus 12x squared. And now we subtract these two things from each other. 6 cubed minus 6 cubed is 0. Negative 19x squared minus a minus becomes a plus. So plus 12x squared becomes minus 7x squared. And then we carry down these 16x and the minus 4 because we haven't used it yet. Now once we've done this, and we have a new function on bottom here, we simply go back to step 1 until we run out of new terms. So remember, step one was we look at the highest power of the polynomial, and we divide it by the highest power of the divisor. And whatever that turns out to be, we write that on top of the hat here. So negative 7x squared divided by x is minus 7x. Now we'll multiply it by the divisor. So this becomes minus 7x squared plus 14x. And we subtract that off. And we'll get a 0 here. 16x minus 14x is plus 2x minus 4. And again, same thing. 2x divided by x is 2, so plus 2. And now we do 2x minus 4 minus 2 times x is 2x, 2 times negative 2 is minus 4. So we have a 0, and now we've run out of terms. So what this says is that 6x cubed minus 19x squared plus 16x minus 4 divided by x minus 2 is equal to 6x squared minus 7x plus 2. And sometimes we take this x minus 2 in the denominator here and multiply it to the other side, and instead write 6x cubed minus 19x squared plus 16x minus 4 is equal to x minus 2 times 6x squared minus 7x plus 2. And this second term right here is exactly the question mark that we were trying to find before. As well, this is a simpler function that we can factor. So long division allows us to take complicated polynomials and start reducing them until it's something quadratic which we know how to factor. So why don't we finish this off here, and we'll try to factor 6x squared minus 7x plus 2. If we remember what the steps were, is to do a times c, which is 12, and then find two numbers that multiply to be 12 and add to be negative 7. Well, these two numbers are going to be negative 3 and negative 4. Negative 3 times negative 4 is positive 12, and negative 3 minus negative 4 is negative 7. So then we change this to be 6x squared minus 3x minus 4x plus 2. Then we group them up and simplify. And remember, when we group up a negative on the outside here, that will change all of our signs here. So this becomes 6x squared minus 3x minus positive 4x minus 2. Now we simply pull out the like terms. Oh, this is x minus 1. Pull a 2 out here. And we'll have 2x minus 1. And then when we have the same thing inside the parentheses, we let that be its own part, and we let the part outside the parentheses be our second part. So now we've completely factored this, and our factors are x minus 2, 2x minus 1, and 3x minus 2. Now this worked out because we knew that x minus 2 could divide our original polynomial. However, this isn't always the case, and sometimes we'll have long division with remainders. So let's see how this works by dividing x squared plus 3x plus 5 by x plus 1. X plus 1 is our divisor, x squared plus 3x plus 5 is our original function. And now we just start with our process. Okay. Our leading term in the original polynomial is x squared. Our leading term in the divisor is x. X squared divided by x is just 1x. Now we multiply and subtract. X times x is x squared. X times 1 is x. X squared minus x squared is 0. 3x minus x is 2x. We bring the 5 down and we repeat. Now what is 2x divided by x? Well, the x's will cancel out, and what we're left with is just plus 2. And this becomes 2x plus 2. We subtract it off and we have 0 plus 3, and this is our remainder. We can't go any further with the long division because 3 divided by x isn't a simple number to keep dividing by. So how we write this is we say that x squared plus 3x plus 5 divided by x plus 1 is equal to x plus 2 plus 3 divided by x plus 1. We can't simplify that term anymore, so we just simply leave it alone. And the 3 is on top because that's our remainder. And the x minus 1 is on bottom because that's our divisor. Again, we can sort of cross-multiply this bottom over and say this is the same thing as x squared plus 3x plus 5 is equal to x plus 1 times x plus 2 plus x plus 1 times 3 divided by x plus 1. But these cancel out since we have the same thing on top and bottom. So we can simply write this as plus 3. And again, we can see this is our remainder. It doesn't factor out nicely. All right, let's do one more example here. And for this example, we're going to have a more complicated divisor. However, the process remains exactly the same. So we see, okay, 2x to the fourth is our highest term in the original polynomial. X squared is the highest term in the divisor. And over here, maybe we'll keep some mental math space. 2x to the fourth divided by x squared is 2x squared. And that's the number that goes on top here. Every time, it's just the same rule. Okay, now that we know what the term on top is, we just multiply out and start subtracting. So this becomes 2x to the fourth plus 4x cubed minus 6x squared (2x to the fourth minus 2x to the fourth is 0. 4x cubed minus 4x cubed is 0. Negative 5x squared plus 6x squared becomes plus 1x squared. Remember, minus a minus becomes a plus. And then we carry down the plus 3x and the minus 2 because it hasn't been involved yet. All right, now the highest term is x squared. The highest term in the divisor is x squared. So we simply do x squared divided by x squared is 1. And we tack on a plus 1 here. Multiply everything by 1. It's not going to change anything. So we'll write x squared plus 2x minus 3. Subtract all these things. And we'll get 0 plus x plus 1. So now x plus 1 is our new polynomial to divide by. But since if we say, okay, what is x divided by x squared? Well, that's 1 over x, which is bad. So this means we're done. We can no longer simplify, and x plus 1 is our remainder. So we can finish by writing 2x to the fourth plus 4x cubed minus 5x squared plus 3x minus 2 divided by x squared plus 2x minus 3 is equal to 2x squared plus 1. What's on top of the polynomial here? Plus x plus 1, our remainder down here, divided by the divisor. Gotta love every time I do that. X squared plus 2x minus 3. Or again, we can carry this denominator over and say 2x to the fourth plus 4x cubed minus 5x squared plus 3x minus 2 is equal to x squared plus 2x minus 3 times 2x squared plus 1 plus x plus 1. Just add the remainder onto the end. And now we can see that even with higher level divisors, if we have an x squared or an x cubed, the only thing that becomes more complicated is the remainder. The process always remains the same of just dividing the largest term in the polynomial by the largest term in the divisor, and keep going until you end up with something weird such as 1 over x, or maybe 1 over x squared. To finish off this section, we have a skill check. So try and do this long division on your own, and the answer you should get is x squared plus 7x plus 18, with a remainder of 42.